Hello Math 8 students, this is Utah Middle School Math Project 3.1a, Writing Equations in Slope-Intercept Form. We recently finished our proportions and linear relations topics. This is where we're going to tie it in together to kind of a related but also a somewhat new topic, graphing and systems of equations. So we need to make sure that we're really proficient in looking at a graph, looking at a table, being able to write the equation, so when I reverse it and I give you just the equation, you still know what you need to do. So let's put this all together. You and your friends go to the state fair. Costs $6 to get into the fair and $2 each time you go on a ride. This problem sounds familiar, right? We've had this one before. So you need to look at the relationship that you see in the table, see how it relates to the story. Look at the relationship in the graph, again, see how it relates to the story and the table. With that, will you please write the equation? Students in class have already had time to do this, so they're ready to respond. Pause and make sure that you give yourself a chance to do that. What is the equation for this relationship that we see in the story, the table, and the graph? Danielle? Yeah, y equals 2x plus 6. That's great. Where do we see the slope? We can see it in the graph, we can see it in the equation, and we can see it in the context in the table. Where exactly is that coming from? So let's start here in the equation. Where is that slope? I've always used a certain color for it. What color did I use here? Go back and discuss then. You can write the equation, but we need to understand what it means. Slope. Okay, what is the slope? Let's take a look at the equation. How can I find the slope just by looking at the equation? I'm going to start cold calling Luke. You made eye contact, so that means you're ready to answer. Okay, looks like Caden's ready to help you out. It is 2 over 1. Where do we see that in the equation, though? In the equation. You're right, it's 2 over 1. Where do I see that in the equation? Gabe? Yeah, it's what's multiplied by the x. What do you see right here? 2. What color did I color it? Because this is the slope. Tying it into the place that we normally look for slope, which is the graph, as Caden pointed out, 2 over 1, crosshair to crosshair, right? But then I would say, Caden, it's not going up 2, it's only going up 1. What would you say to that, Caden? Exactly. I might just be going up 1 box, right? But I'm going from 8 to 10. That means it's changing by 2. So up 2 over 1 box because we're going from 1 to 2, so 1. So the rise over the run is 2 over 1, or simply 2, which is why we write it here in the equation as just 2. Can you see the slope in the table? Where? Talk with your groups because I should see a lot of hands for this one. Where do we see the slope in the table? Okay, finish up and tell me. Ethan, where do you see it? Where do I see crosshair points in the table, though? No, we moved on from the graph. Now, can we still find that same information that we saw on the graph with those crosshair points? Can we still see that here in the table? Ethan, do you want to answer? Exactly. Yes, exactly right. The y values are going up by 2 every time the x values are going up by 1. So yes, we can still see the slope in all of those places. Where do we see the slope in the story? Relate it back to the context now. Again, we know the slope is 2, right? 2. Up 2 over 1. Where do we see that information in the story? Reread that story again if you need to. Gabe, where do you see it? Yep. $2 each time you go on a ride. That's exactly right. Now, I just kind of made marks on my paper. Let's quickly write it down in our notes. What is the slope of the graph? That was 2, or 2 over 1. Where do we see that in the equation? The equation was the value multiplied by x, or the coefficient of x. Coefficient of x just means, in fancy terms, the number multiplied by x. What does that slope represent? Remember, in our graph we saw the rise over the run, but for a context, that rise is representing $2 for every one ride. So we have equation, we have context, we should even maybe put on here in the table. We saw that the y values change to, go up to. Every time x goes up by 1. It's a good review, right? It's been a while since we looked at these, so good review. Now, what about the y-intercept? What is the y-intercept of the graph? Let's look at that first. Where is it crossing the y-axis? 6. Where can you see that in all of the representations? Where do you see that in the equation? Where do you see it in the table? Where do you see it in the context or the story? Quick discussion with your tables. We'll just come back together in about 20 seconds. Ready, set, go. I'm going to pause the recording. Okay, where do I see that 6 in the equation? Let's start there. Where is it in the equation, Maverick? Yeah, where we're adding 6. So we can see in the equation the y-intercept. Where do I see it in the table? Where can I see that 6 in the table, Sam? I want us to be careful about that because but I don't see a y-axis here. If I'm looking at the graph, yes. But when I'm looking at the table, exactly, when the x value is 0, sometimes I'm going to start in the negatives. Sometimes I'm not going to show you the y-intercept at all. Maybe I'll start here at 1. So we have to be careful about where it starts. We specifically want to know when the x value is 0. Why? If it's the y-intercept, it's on the y-axis, which means how far over am I going in the x's? Going over 0. So it's when that x value is 0. What does it mean in the story? When I relate it back to the story, what does that mean? I've already called on those hands. I need to see new hands. There we go, Emery. Yeah, $6 just to get into the fair. That's exactly right. So we talked about it. We made marks. Let's now also put it into words here. When we see the graph, it is exactly where Sam said it's where it crosses the y-axis. Okay, and the equation. You said that's where we're adding 6. In the context, we have to pay $6 just to get in to the fair. And the table, very specifically, be careful that you don't write down where it starts. On the table, we see it when the x value is 0, y value is 6. Now, looking at this example, reviewing what we did previously, we can see that one way to represent a linear equation is in slope-intercept form. Slope-intercept form. That would be when the equation of the line is y equals mx plus b. It is called slope-intercept form. Will you please discuss with your groups why do you think this particular equation is called slope-intercept form? Quick discussion at your tables. Ready, set, go. Pausing the recording as students discuss. Why do you think it's called slope-intercept form? Jaden? Exactly. Why is it called slope-intercept form? Because it shows us the slope and it shows us the y-intercept. Where can we see the slope? The slope is the m. Recall that up here, the coefficient of x, the number that is multiplied by x. So when you have an equation in this form, you see, hey, look it, there's a number multiplied by x. That makes that the slope or the rate of change. We can also see the Specifically, this is important for a future lesson that we don't get this mixed up. It says intercept, but specifically we are seeing the y-intercept. Where do we see that y-intercept? It's our plus b, whatever we're adding. Or in some cases when we're subtracting, we'll have to think about what that means. B represents the y-intercept. Sometimes it's called the initial value, like the value that we would have to pay just to go into the fair, where we're starting out. So if we are given a representation of a linear relationship, you can write it in slope-intercept form. Just know the slope, know the intercept, and substitute those values in. Here is one thing that is really important to recognize, again, for a future lesson, something we're not going to encounter today, but another day, probably 2 to 3 days from now. I want you to recognize this. Y is alone. Okay, it's y equals, and then we have our slope times the x plus the y-intercept. Key thing that you need to recognize about this and get in the habit of seeing it now, y is alone. So let's put this to practice. I'm going to abstract this a little bit more. Sometimes when we have all those representations and we have a story, it makes it really easy, but can you still write the equation when I take away all of those contextual cues? I just tell you the slope of the line is 3 and the y-intercept is 0, 4. Can you write the equation of that line? Give it a try with your groups. Talk with each other. I'm going to keep the recording going. How can I write the equation of the line? There's no more story, there's no more graph, there's no more table. How can I write the equation of the line given only this information? Ready, set, go. Okay, who thinks they're ready to give it a try? Number 1, what do you think the equation is? Luke. Exactly right. Y equals, how did you do that though? How did you know that it was y equals 3x plus 4? Yes, exactly. The slope of the line is 3, and here when the slope of the line was 2, we multiplied that 2 by x, right? The m is our slope, and that is multiplied by x. So we know that the slope is 3, so the 3 is multiplied by x. How did you know what to do with that plus 4? Yeah, 0, 4 is the x value, where the x value is 0, and the y value is 4. That means it's going to be intersecting that y-axis here at 4. And going up 3 and over 1. So y equals 3x plus 4. You got it. Put that to practice. I'm going to pause the recording now. Yes, do we have a question, Brooke? No? Okay, 2, 3, 4, and 5. Put it to practice. Write those equations. When you're ready, we're abstracting it in a different way. Now it's going to be graphs. Can you still write the equation? And then after that, it's going to be just tables. So see what you can do, and we'll step by step on each one. But if you get bored of 2, 3, 4, and 5, move on to the other ones. Pause the recording now as you try 2, 3, 4, and 5. Ready, set, go. Okay, only continue on in the recording if you've already answered 2, 3, 4, and 5. We're just checking our answers and discussing. Lance, give me 2. Yes, exactly. Y equals negative 2x. Notice Lance didn't say anything else after that, right? But why? Shouldn't we have a plus what the y-intercept is? What would we do if we did write that? What would it be? Plus 0. And is that okay to write that down? Yeah, but aren't we feeling kind of lazy? Yeah, because you're all mathematicians. Mathematicians are lazy. So what is the point of adding that plus 0? We're lazy, so we don't. Means the same thing, though. Okay, great job. Let's do the next one, number 3. Give it a try, Charlie. Yes, exactly. I'm so impressed that you knew what to do with that, because all the other ones have been plus a number, right? But what would our number be if we added it? Negative 2. So could you write plus a negative 2? Yes, but if we're feeling kind of lazy, maybe we'll just go straight to minus 2. Means the same thing. Yeah. Questions? Okay. Next one then. Go ahead, Brock. Yes. Y equals negative 4/3 x. What did you say at the end? Yeah, plus a negative 1. Is that okay if we write plus a negative 1? What else could you have written instead of plus a negative 1, Jaden? -1, yeah. I'm going to leave it plus a -1 since that's how the student presented it, but it would be the same as -1. And last one, this is an interesting one. Give it a try, Peyton. Yeah, it is y = 0x + 2, but now tell me, folks, are you feeling kind of lazy? I'm feeling lazy. If we have 0x, yeah, I have no fish. So when someone asks me about my pets, do I tell them about my fish? No, so why would we tell them about something that we don't have? How many x's do I have? None of them. So what we could do is just say y = 2. And you are going to have some problems like this. What I want you to do is when you see an equation that looks like this, y = 2, understand that that means 0x. Understand that that means the slope is 0. Envision what that looks like right now, so when you see it later on, it won't be such a surprise. Discuss with your groups, what is this line going to look like? We know it has a y-intercept of 2. What is it going to look like? Quick discussion at your tables. Okay. What do you think this line is going to look like? Sam, what do you think? Well, it doesn't mean that there's no rise and no run. We need to interpret what 0 means. So you're close. It would be a dot. Where would the dot be? Let's start there. Where would the dot be? On the y-axis at 2, right? But what is this line going to look like? Danielle? Yeah, exactly. So 0 is representing the rise over the run. What does that mean? That means we have a rise of 0. What could our run be? Anything. Because 0 divided by 5 is the same thing as 0 divided by 1. Right? Both of those simplify to be 0. So what is this line going to look like? It is going to be well, they're all straight lines, right? It's going to be a horizontal line with no slope. What is the slope of this line? 0. It has no rise and all run. Okay, great job. Yes, Jaden. How would we represent a vertical line? You will be seeing that soon. I don't want to give it away just yet. I think that's a great thing that we can be thinking about in the meantime, but we will get there. What would that look like? Maybe discuss at your tables now while I prepare for the next one. What would a vertical line that is all rise and no run, how would we write that equation? Talk to each other about that. See what you think. Okay. Hold on to those thoughts. We will come back and address them later on. For now, I'm giving you the graph this time. I'm not specifically telling you what the slope and the y-intercept are. We have to find it. Can you find the slope by looking at a graph? Yeah. Can you find the y-intercept by looking at a graph? Yeah. Let's do the first one together. We need to be able to write this in that form, y = mx + b. So I need to find the slope. I need to find the y-intercept. Let's start with the y-intercept. That's easy. Where is it going through the y-axis? At 2. So we know that the y-intercept is 2. Now we need to find the slope, or the m value. This is where we got to find some crosshair points. Can you find some crosshair points? Here's one. The y-intercept is 1. Look very carefully, and I printed yours small, so hopefully you can still see. There's a crosshair point. Did you guys find the same one as me? There's a crosshair point. What is that slope? Looks like I'm going up 1 and over running a +3. So the slope is 1/3. Let's write that equation of that line then. Y is equal to, oh, I didn't realize that there's a spot down here. M is equal to 1/3. The B was equal to 2. So when we write it in y = mx + b, y = m 1/3 x plus 2. Exactly. Y = 1/3 x plus 2. I think you're ready to practice this with the others. Looks like we have 7, 8, 9, 10, 11. I did one together with you. You guys work on the others. We'll come back together to check the answers. So pause recording until you have 7, 8, 9, 10, and was it 11? How far does it go? 11. Yep, 7, 8, 9, 10, 11. Get those done and then continue the recording. Pause recording now. All right, here's number 7. I had a slope of -1. That would be -1 over 1, which simplifies to -1. A y-intercept of 3, so I'll wait. Thank you. On number 7, I have the equation y equals -1x plus 3. You know another way you might also see that. Y equals -x plus 3. Understand that sometimes we're just lazy. So what is the coefficient? What is a number being multiplied by x? When I see it like this, it still is -1. But sometimes we're just too lazy to write it. So just understand that. Let's take a look at the other ones. I've already found the slope on these ones. Number 8, did you guys get the slope of 5/2? Yeah, got to be careful on those crosshair points. So we're going up 5 and over 2. For a slope of 5/2, what is the y-intercept? Y-intercept on number 8. Come back with me. Don't keep trying to work ahead. Come back to me. Number 8, what is that y-intercept, Gabe? -3. Therefore, the equation is going to be, did you guys get y equals 5/2 x minus 3? Great. Okay, equation, or the slope on number 8. Sorry, number 9. I have a slope of -3 over 1. We're falling 3, so that would be -3. Running to the right 1, so -3 over 1, which does simplify to -3. And the y-intercept is the origin, so 0. What is the equation then? Gracie? Yes, y equals -3x. When we don't have a plus b, what does that mean? It means we were just too lazy to put plus 0, but we know that it's going through the origin. Great job. Number 10, I did not find the slope yet. What did you get for the slope, Maverick? Yes, looks like it. And -2 over 1 simplifies to? -2, good. And what is the y-intercept? Gabe, 8. And so that makes the equation what, Danielle? You got it. Y equals -2x plus 8. And the slope of number 11. Slope, for anybody who has it. Thank you, Sam. I don't think it's 1/2. If I go up 1 and over 2, it doesn't look like it goes right exactly through that crosshair point. And I can see that because mine is blown up nice and big. Here's a great way that you can check. So I'm going to start at that y-intercept and go up 1 over 2. It looks like maybe crosshair point. Let's continue though. Up 1 over 2. Is it still looking like it's going through the line? Up 1 over 2. Is it still looking like it's going through that line? No. So that's a great way that you can check, because sometimes those crosshair points can be hard to find. Who has a different slope that they want to check it out? Emery? 3/5. Let's see. Up 1, 2, 3 and over 1, 2, 3, 4, 5. Yeah, that definitely looks like a crosshair point. So a slope of 3/5 seems to work out better than that 1/2. And y-intercept is going to be, I have -3, yeah? And that makes the equation what? Anyone who wants to tell me? Thank you, Maverick. Go ahead. Good. I love how you gave us options. Plus a -3 or just -3 if you want. Great job. Now, are you ready for these challenge problems 12 and 13? We had a question earlier. What is the equation going to look like when it's straight up and down? Now we have an example. This line is going straight up and down. What is that equation? Let's start. What is the slope? What is the y-intercept? Discuss with your group. What is that going to look like? Any thoughts? Jaden? Okay, this is an undefined line. You're absolutely right, because what is the slope? Well, what is the slope? Be careful. There's a right way to answer this. What is the slope? What's the rise over the run? All rise, no run. And if it's all rise, no run, it's undefined. Exactly. All rise. So we could say that the rise is 5. Like to go from here to here, we're rising 5, right? What is the run? What happens when we divide by 0? Try again. What happens when we divide by 0? Undefined. So how are we going to write an equation where it's always the slope times x, but the slope is now undefined. We're running into a challenge here, right? Let's keep going though. What's the y-intercept? It crosses at 0? It doesn't. It's never going to, right? So what is the y-intercept? None. It doesn't exist. So how in the world am I going to write an equation that is supposed to have an undefined slope and a non-existent y-intercept? Are we going to be successful with this? Maverick has a thought. Let's go to voices off. Let's listen to Maverick. Good try. But no, it is not y equals undefined x plus non-existent. Good guess. Are we going to be successful writing an equation in this format? No. So we've got to write an equation in a way that we can. Fitz, you had your hand up. You had a thought? It's not y equals x though. Think about what it would mean if it was y equals x. Could we find the slope? What's being multiplied by x? 1. What are we adding? Nothing. So this would be the equation that goes through the origin, and we go up 1 over 1, up 1 over 1, and y equals x would look like this. Right? So that's not it either. Good thought. Sam. It's not just y either. No, it's not y either. Maverick, last. It is not undefined. So here's what we have. Are you watching? Does it have a y-intercept? Does it have an x-intercept? Yeah. Where is it intersecting the x-axis? At 1. Guess what? That's the equation of the line. Because what is the one thing that is consistent everywhere in this whole thing? X value is always 1. What is the value of x here? What's the value of x here? And up here? What's the equation then? X equals 1. Because that's the only thing that we know, is that no matter what, x is always 1. This is different, right? Why is this different? Remember how back here I told you the y is alone. We're always going to have a y equals. But if y is alone when we have a y equals, that means that we have to have a slope and we have to have a y-intercept. And what do we have here? No slope, or an undefined slope, a non-existent y-intercept, so it cannot be in that same format that we're used to. So we write x is equal to 1. You're not going to see that very often, but when you do encounter it, I want you to know what it means. With that in mind, what is the equation of 13 going to be? We already have some thoughts, right? We kind of hinted at this earlier. What is this line going to be? Let's talk with our groups. And then I want to see more hands. Number 13, what is the equation? Okay, come back to me now. What is the slope of this line? Gracie. Yeah, the slope is 0. Because pick any 2 crosshair points. How much am I going up? 0. What's the run? Depends on what crosshair points you picked, right? But 0 divided by 5 is equal to 0. What's the y-intercept? Fitz. Yes, -3. I heard one of my rulers being bounced and misused. Remember, they are tools, they are not toys. Y-intercept is -3. What is that equation going to be then? There should be more hands. I'll wait until I get more hands. Siley. Yeah, y equals -3. Is this in the same format as the y equals mx plus b? Yeah, it is, right? It's 0x, and so if it's 0x, we're too lazy to put it, but it is still in the same format. Is this one in that same format? No, because it couldn't possibly be, right? The slope is undefined, the y-intercept is non-existent, so this one has to be in a different format. This one appears to be in a different format, but it really truly is in the same. And now we're going to put this all to practice. We've got some tables and we've got some stories. And that is as far as we're going to make it in this lesson. Let's see what we can do. Number 14. Can you find, let's start with the y-intercept here on the tables. Can you find the y-intercept? Where is it? Yes, it's when the x value is 0, the y value is 4. Is it always going to be the top row of the table? No, look at number 15. What is the y-intercept? -2. It's when the x is 0, whatever that y value is, -2. let's go back to number 14. Can you find the slope? How do we look for the slope when all we have is a table, no other context, nothing else to see? What would you do, Gabe? Yeah, look for the changes in the x and the y. How much are the y values changing? Up to, every time the x value changes, 1. So that means a rise of 2 and a run of 1, or simply 2. What is the equation going to be? Y equals, Luke, give it a try. You got it. Y equals 2x plus 4. Let's finish up number 15. We already found the y-intercept. Can you find the slope? Check in with your groups first and then we'll come back together. What is the slope of number 15? Number 15, did you get a slope of -1? Yeah, because we're going down 1 every time the x values change 1. So that would be -1 over 1, which simplifies to -1. Therefore, the equation is y equals, I'm going to be lazy here, and I'm just going to say -x minus 2. We're running a little bit short on time, so I'm going to try and make time for 16 at the end. If not, that one is going to be your homework. Let's move on to 17, 18, and 19, where now we have a story. No graph to look at, no table to give us clues. All we have is a story. You're going on a road trip with your family. You are already 30 miles into your trip, and the speed limit is 75 miles per hour on the freeway. Let x be the number of hours from now, and y be the total distance traveled. What would be the slope, and what would be the y-intercept? Let's use that to make our equation. Talk with your groups first. Let's come back together in about 15 seconds. What do you think? Okay, what is the y-intercept? What are your thoughts here? What's the y-intercept? Let's go Brock. Why do you think it's 30? Yeah, it really, truly, they started a while ago, but they're like, from right now, this is our new starting point. And where are we at this new starting point? 30 miles into the trip. So the b value, that y-intercept, our initial value is 30. What is the slope? How is it changing? How is this changing? Sam? Yeah, 75 miles per hour. The fact that it's giving us a rate, 75 miles per hour, that's kind of our clue there, that that's the ratio or the rate of change or the slope. With that in mind, we can write the equation. Y equals 75x plus 30. Okay, let's see if we can do at least number 18, leaving you with only 16 and 19 for homework. A basset hound weighs 100 pounds and is on a special diet to lose 4 pounds per month. X is going to represent the number of months passed and Y the weight of the dog. What's the y-intercept here? Jaden? 100. That's the starting weight of our very heavy basset hound, 100 pounds. What's happening? How is it changing in this story? Kaden, S. Exactly, -4. We're losing 4 pounds, so that's going to be -4 over 1 or -4. Therefore, the equation is y equals -4x plus 100. Your homework is 16 and 19, not very much. You're probably already done with it because you worked ahead. We will finish this packet on another lesson. That's it for today. Thanks for watching. We'll see you next time.